Alright, today we're going to be discussing comparing or ordering fractions. This is in the TEKS, I'm sure it's in Common Core, and it's definitely a question that comes up on STAR exams, especially for the third grades and higher. So before we get started, let's first review a little bit of equality. So let's say I have 5 is equal to 5. Recall that we defined equality of two numbers to mean that those numbers are at the same spot on the number line. So if I take the left side of this and add 2, that means I took 2 steps, right? So in order for the right side to still land at the same spot, I got to take 2 steps as well. So now we're at 7 equals 7, right? So if I take 2 steps on one side, I got to take two steps on the other side to ensure that we are landing at the same spot. The whole point of saying that is that saying that we heard all through junior high, high school, when we're working with an equation or with equality, what you do to one side, you have to do to the other to ensure that equality stays so that our values are still ending up at the same point on the number line. We just did it with addition. Subtraction, it works the same exact way. I got to take steps back, and it works with addition, multiplication and division. So let's look at a couple of things with numbers real quick, and then we'll look at it with letters. So let's say that I have 24 divided by 3 is equal to 16 divided by 2. And take just a second, make sure that you agree with me that these two things are equal. They will land at the same point on the number line. Hopefully you see that. Yes, 24 divided by 3 gives me 8 with a remainder of 0, and 16 divided by 2 is also 8 with a remainder of 0. Alright, so these two are equivalent. And again, what I do to one side, I have to do to the other. So I'm going to start by multiplying both sides by 3, right? I want to multiply the left by 3, and I want to multiply the right by 3. So if I multiply the left by 3, I get 3 times 24 over 3. And if I multiply the right by 3, I get 3 times 16 over 2. Now on the left, we've looked at equivalent fractions and reducing by the common factor. So here I do have a common factor, and I can cancel out these 3's. So I just get 24 is equal to 3 times 16 over 2. The way this is written, I don't have a common factor, so I'm going to leave it as is just to show my point. So I got rid of this denominator by multiplying by 3. I'm going to do the same thing over here, multiplying both sides by 2. So on the left, I get 24 times 2. On the right, I'm going to get 2 times 3 times 16 over 2. And again, I have a common factor here, so I'm going to cancel that out. Boop, boop. So I get 24 times 2 is equal to 3 times 16. And I want to check, do these still land at the same spot? 24 times 2 is 48, and 3 times 16 is 48. Absolutely. So what was the point of doing any of that? So this is a way to compare fractions. Now we just did it the long way, using equality and taking it one step at a time and canceling out the common factors. If you come down here, can you figure out what the shortcut would be? Just to be able to jump from here to here. What happened? Alright, so hopefully maybe you see that we cross-multiplied. And this is how you'll solve a lot of your proportions and things like that. So the shortcut of this here, in between is all the why can we do that. The shortcut is just cross-multiplying 24 times 2 and 3 times 16. Now the significance of this is that when we cross-multiply, the two values were equal, so we can confirm that these two fractions are equivalent fractions. Now, if I don't have equivalent fractions, or if I'm not sure if I have equivalent fractions, or if I'm trying to order my fractions, I can still use this cross multiplication. So let's say that I have, real quick, I want to look at a simple ordering. So let's say I have 1/3, 1/5, and 1/4. Since they all have a numerator of 1, and I'm just dealing with these single unit fractions, these are pretty simple to put in order. I know that the denominator shows me how many pieces the unit was broken up into, and 5 pieces is going to be, each piece is going to be smaller than 4, which is going to be smaller than 3. So if I'm ordering this least to greatest, then students should know this is 1/5, 1/4, 1/3. This is least to greatest, right? So no trickery is really needed. But if I have 2/3, 4/5, and 3/4, things get a little hairy. So our cross multiplication trick comes in handy with being able to order or compare them. So I'm going to start with just 2 real quick. I want to know let's do 7/8 and 4/5. They're both pretty close to a whole, right? This is 7 out of the 8 pieces, and this is 4 out of the 5 pieces. So they're both pretty close to a whole, but which one is bigger? We can use cross multiplication to see. So 7 times 5, this gives me 35. I'm not even going to write the whole thing out. And 8 times 4 gives me 32. What that indicates to me is that 7/8 is larger than 4/5. And so let me break that down real quick. The number that's on top that got multiplied, so here the cross multiplication, 7 times 5. Here's the numerator that I used, so I put that product on top of here. So the 35 goes with the 7/8. And then 8 times 4, 4 is my numerator, so 8 times 4 is 32, and 32 will represent, I use that term loosely, my 4/5. And so this, now I can make the comparison of 35 and 32. We know that 35 is larger than 32 because it requires 3 more steps. So 7/8 is larger. And we can introduce our inequality symbols here. I know I got a lot of stuff written out here. 7/8 is greater than 4/5, or 4/5, right? You can use whatever wording you want to with this. The open mouth always eats the bigger number, or we could draw the little alligator teeth, or whatever you want to do. This is the greater symbol, right? And we could write it the other way. If 7/8 is greater than 4/5, then that means 4/5 is less than 7/8. Notice that the open side is still facing 7/8, but when I flip it the other way, we read words left to right, and we read mathematics in the same way. So 4/5 is less than 7/8. All right, so the big picture here, being able to actually order fractions. So I had the example. We want to write or order, what did I say, 2/3, 4/5, and 3/4 from least to greatest. So I need to make some comparisons here. So I'm going to start by comparing these first 2 fractions. So 2 times 5, that gives me 10, and 3 times 4, that gives me 12. So I know that 2/3 is smaller than 4/5, so it's going to come before 4/5 in my list. So let's compare these last 2 real quick. 5 times 3, I'm going to write it here on the bottom, 5 times 3 is 15, 4 times 4 is 16. So I know that 4/5 is larger than 3/4. 4/5 is also larger than 2/3, so I know 4/5, since I'm going least to greatest, 4/5 is going to be my last number because it's larger than the other 2 numbers. So 4/5 goes last. Now the only comparison that I need to make is between 2/3 and 4/5. Which one should be the very first, so which one is the smallest? So I'll come off to the side, 2/3 and 3/4. 2 times 4 is 8, 3 times 3 is 9, and that indicates that 3/4 is larger. So 2/3 is smaller than all the other fractions, so 2/3 goes first, and 3/4 comes next. And there we go. I didn't have to convert and round any decimals, any division, or anything like that. A simple cross multiplication allows me to compare and therefore order all of the fractions.